Hello, right now I'm going to start with Leetcode 120 problem, triangle. So, given a triangle array, return the minimum path sum from top to bottom. So for each step, you may move to an adjacent number of the row below. More formally, if you are on index I on the current row, you may move to either index I or index I plus 1 on the next row. So this means, imagine we're here on the first row, it's index 1. Then for row 2, then we can move to either 1, oh, it's 0, right? So we can go to either 0 or 1. Imagine we stay at 0, then we can go 0, 1 again. Or if we're at 1, we can go to 1 or 2. So yeah, this one can actually only come from this one. This one can only come from this one. This go to these two, this would go to these two. It's very straightforward. Uh, so yeah, and another thing is that they can be also negative numbers. I can see here. So it could have a -8 here, and yeah. So brute force, like the first thing I'm thinking is, okay, so uh, can we be greedy? No, we cannot be greedy. Why? Because imagine here it's like a 4 and a 3, and here's a 1, so we go this route, but here's, instead of a 7, we could have like a -20, right? So if we are by here, and this is a very big difference in like being negative or just like this is a bad path, we will never be able to get here. So a greedy approach will not work here. I feel like the camera is like a bit like stalling sometimes. I hope it looks kind of good because I really don't want to edit, and now I won't edit. Yeah. Anyway, so yeah, we want to be able to have the best approach. Initially, something like I may think is like, okay, we can start from bottom up. So like I know this is the best route, which is the best way to get here 5, which is the best way to get here 3. However, again, really, so like I think this is not the best way to think about it. I have here an Excalibur route to just think about this problem a bit more. So I'll have 1, 2, 3, 4, 5, 7, -2, 8, 9, and -10. So here, like, I know I will always have 4 possible best routes, right? So here we'll have, what's the best way to get here? Well, it's actually just straightforward. So it would be 4 plus 1, 5, because the 2 cancel out. What's the best way to get in this exit? It will be first 4, then 2, 1. So 15. What's the best way to get here in the 9? It would be 9, then 5, then 2, then 1. So 10, 17. And here it would be 3, 6, 7. Okay, so actually this is the best route, even because of the 7. Oh no, I'm sorry. Yeah, no, my bad. This is, yeah, I sometimes speak without thinking. So this is 10, 10 minus 10 equals 0 plus 1. So yeah, this is actually the best optimal route. So yeah, I feel like the best way just to make this intuitively and just avoid following a greedy approach, even if we are not really thinking about it, is just being realistic. We'll always start here, and these paths are possibly not are possibly changing. So if I know I have an array of, here's first size 0, well, size 1, then size 2, size 3, then size 4, I feel like I can just update the sizes. Well, not the size, but like update the weight. That way, when I reach the final row, uh, like I'll have the realistic, like sort of a DP approach or dynamic programming. So for example, here I know one is the only way to get through either two or three. So here I could maybe update this to be like a 3 and here a 4. Now from here I can go to the 4 or 5. I'm not really sure if I go to 5, then here it could be like a -9, right? And if I go with a 4 here, it will be unable to actually go to like the peak, well, not the peak, the minimum route. So just update each of the children of any node or any number in the pyramid with its lower volume. So I feel like our algorithm could just be checking for I on each row, just update based on uh, is this better than the current, is this better in the, if it's if this is I, then check if possible itself or I minus one, right? So here it there's not a second index here, but there's an index minus one, so you will have to check both. For example, I feel like this is a better example. Its index is 1, so I need to check index 0 and index 1. So here I know that the best path here, it would be to add this value. What's the best way to add this is with this value. So instead of 3, it will be 5 plus 3 is going to be 8, right? Now here, what's the best way to get here is from the 3. So 7. I feel like I'll just erase this a bit here. So here it was a 7, here's an 8. Here the only way to get is like 7 plus 4, so it's going to be an 11. And then to get here, instead of a 7, it's a 5. Here it's a 16. Here it's either 8 or 11. Oh, my bad. Actually, to get here, it can be either 8 or I minus 1, so it's 7, so it's going to be 15. This is my first time recording like a Leetcode. My bad. I'm sorry. 11 or 8, it's best 8. So 9 plus 8 is to what? 17. And this is the only way, so it's actually going to be 1. So we know this is the best possible value. And we don't have to have like an extra array, because I do remember that it said here, like, could you do this using only O and n extra space, where n is the total number of rows in the triangle? So like just have an array of counter for each of the different values. However, with this we skip this and we just keep on updating on the original array of instructions, and we are allowed to edit. There's no restriction on that side. So yeah, that being said, I'll start here. So I know like the first the root of the triangle will always be added, so I can just start from int row equals 1. Yeah, so I'll just add first if triangle dot size equals 1, then just return triangle 0. Yeah, so if there's only one row, there means it's only like this value, so that's one edge case. Then for row starting with 1, and it's going to be row has to be less smaller than triangle 0 triangle that size. So like this array, yeah, so this array, and then row will have to go up, well, technically down, so like, you know, this is 0, this is 1, this is 2, this is 3. Then we have to start with each of the different items. So we know like the first item only path is always the first of the past row, and we know the last is always plus the last value, right? So I'll just add here so it will be row, it will be triangle row, and then the first plus equals what's triangle row minus 1 0, right? Like the first value. And then I also know that the last one is always going to be just from the last one. So yeah, I can just here row is going to be, so for the first one it's going to be 1, for the second one, well, yeah, 0 0 1 1 2 2. Actually I can just repeat this here because column 1's index 1, column 2 technically index 2, because you know 0 indexing. So plus equals triangle, oh my bad, triangle row negative 1 row negative 1. So this value is going to be to the past minus 1 for all, and then for integer column we're going to start at first, and call has to be less than row. So for example, if we are in the fourth row, it's technically the index 3, right? So for the third we want it to be less than third, so 0 1 2, so it's going to be less than row. Okay, and call pass. Okay, let's go, and we will just check. So triangle row and then the column plus equals the minimum between either triangle row negative 1 and call negative 1. So like, for example, for the first it would be 0 or 1, or so yeah, so 1 passed or exactly indexed in the same size. So for 5 it's either index 0 or index 1, which is the same as index 1. For 8 its index is 2 and its possible parents is either index 1 or index 2. So it's going to be the same except with the last negative 1, right? Yeah, I'm pretty sure about that. So yeah, we will go through each in the middle. So for our first two rows it won't really happen. Call is less than row, so for our first row it starts at 1, so it will be skipped, and it's until the second one. Okay, yeah, I think it's correct. I just saw the camera freeze like a lot, so I'm not sure how it's looking up. Ugh, damn. Anyway, it's alright, like this is a very cheap camera. So yeah, so this should do this, then I guess I can just have here a value int min_val equals its max. So I'll have like a huge number, and so I'll just have this here. For integer I equals 0, I is less than triangle 0, and it's going to be the whole triangle that size -1. Yeah. Plus, so that way I'm going to iterate through. Actually, no, I don't need to. No, yeah, I do need this here, so it's going to be less than the size of the. Oh, I'm missing here a dot size. So yeah, it's going to check the size of triangle 0 in the index of triangle dot size, because if we have 1, 2, 3, 4, then it's going to check in index 3, because I'm doing here, so it will be 0, 1, 2, 3, so this size. Hopefully I'm correct. Yeah. So for integer I equals 0, blah 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 blah. F triangle, and then I'm just going to be so yeah, so it's going to be triangle. Yeah, I'm not sure why the 0 was there. I feel like this is the correct approach. Yeah. Okay, yeah. I'm sorry, I was just like not cooking. So I guess I just have to do this here. So if triangle I is smaller than the min_val, then min_val equals all of this. Then once this loop finishes, I'll have the best value. Return and this, because like it has 1, 2, 3, 4, so it's going to be also 4. And triangle dot size. Okay, like I do need this, however, like this was not needed. Return min_val. Yeah, I was just making this a bit. Hell yeah, first try. Let's go. Come on. Let's go. Okay, yeah.